A very good morning, students. In the last class we were discussing about the Hardy-Weinberg's equilibrium, and we know what is evolution and what is Hardy-Weinberg's law. I just recap what we studied in the last class. Evolution is a change that takes place in a particular organism from generation to generation. So that change is because of genetic flow or gene flow, genetic drift, natural selection, mutation, recombination. So all these are making changes in an organism, and that change is being transferred from one generation to another generation. So that is what evolution is. Hardy-Weinberg law talks about in a large population the changes or evolution will not take place. It means the allelic frequency as well as the gene frequency will remain constant in that generation, in that population, from generation to generation. So no new allele will get inside or no allele will go out of that population. So it will remain constant from generation to generation. And this Hardy-Weinberg law is applicable only if there is an absence of mutation, absence of gene flow, absence of genetic drift, absence of recombination, and absence of natural selection. If all these criteria are being followed, then Hardy-Weinberg equilibrium works out. So Hardy and Weinberg, they have given an equation for calculating the total number of the phenotypes, the total number of the genotypes in a particular population, and that too in a large population, because Punnett square will not help in the larger population to identify the number of the genotypes and the phenotypes in a large population. And that is the reason Hardy-Weinberg equilibrium is supporting us to calculate the genotype as well as the phenotype in a large population. Clear? So that is what yesterday we have discussed. And today's class we are going to concentrate some numericals, some application oriented numerical problems based on this Hardy-Weinberg law. Now some different numerical problems that we will discuss here. The first one is a question that I have given here. If 98 out of 200 individuals in a population, they express the recessive phenotype. You know what is recessive phenotype? No? We studied the dominant and recessive. The dominant is, for example, we have capital A is a dominant. It is represented by P square. And the recessive is small a, it is homozygous condition. It is represented by Q square. And the heterozygous dominant is capital A, small a, it is represented by 2PQ. So now we are going to study out of 98 individuals, that means 98 out of 200 individuals in a population, they express the recessive phenotype. So that means what percentage of the population would be heterozygous? So now here the recessive is given, the recessive allele is given. The recessive allele they have given is as 98, and we have to find out this heterozygous dominant. That is what the question is. So very simple to understand. So first what they have given is the recessive phenotype. The recessive phenotype. So now the recessive phenotype is 98 out of 200 individuals. So 98 by 200. So the q square is the recessive phenotype. It is 98 divided by 200, so it gives 0.49. So this is the actual recessive, that is q square, value of this q square. And this, so if you talk for one allele, single allele, so q. So if q square is 0.49 means the q value is 0.7. Clear? Right. So sorry, we know the formula of p plus q is equal to 1. Now here we got the q value, that is 0.7. So it should be 1. So in the sense the p should be 0.3. So 0.3, 0.7 gives you 1. So p plus q is equal to 1. So this is the recessive phenotype. Okay. So now we got the q volume as well as the p. So now we have to talk about the heterozygous. So here it is the heterozygous condition. So what percentage of the population would be heterozygous? So that is the equation for the formula for the heterozygous is 2pq. Okay, right. So that means 2 into p value is 0.3.3, q is 0.7. Okay, so if you multiply all this, you will get 0.42. So you have to make it in the percentage. So divided by 100. So it gives you 42%. Okay, so that means the percentage of the population would be heterozygous, that is 42%. Clear? So a very simple calculation. These kind of application questions will be asked. Most of the time this kind of a question is a NEET based question, but there are chances even for board syllabus also they will ask these kind of 1 marks or 3 mark questions. So whatever you study in a particular paragraph, everything regarding that you have to understand. Okay, so this is the kind of first numerical problems regarding this Hardy-Weinberg law. Okay, so one more we will discuss. The next question is, if 51% of the population carries at least one copy of the recessive allele, only one copy of the recessive allele, so find the frequency of the dominant individuals. Now here the recessive allele, you have the capital A, small a, then small a, small a. So in this, so here we take this small a as small a is q square. Okay, so plus the heterozygous, it is 2pq. Clear? Right. So we got the value, that is 51 by 100. So 51%. Okay, so this is the value of the q square and this is the heterozygous. Now the formula we know, that is p square plus q square plus 2pq is equal to 1. So this is the formula for this problem. So now here the p square here, the p square is equal to, that is 51 divided by 100, so it gives you 0.51. So here the p square is 1 minus 0.51, so you will get 0.49. This is the value of the p square. Now the second, so the p square is 0.49, so the value of p is 0.7. Okay, so now, so what will be the q that we know, that is 0.3, that is what p plus q is equal to 1. So now the p square plus 2pq. Now here this is the dominant and this is also dominant, both. Okay, that is the reason we have taken p square plus 2pq. So homozygous dominant and heterozygous dominant. And the value is, here you will have the 0.49. It is the p square value. The p square value is 0.49. So we have 2pq is equal to 2 into 0.7 into 0.49. 0.3. So you will get 0.42. Clear? Right. So that is for the heterozygous dominant. So that means the overall the frequency is dominant allele. So P square is also dominant. 2PQ also dominant, but this is homozygous dominant, this is heterozygous. P square value we got it. How? 51 divided by 100, 0.51, and based on the equation 1 minus 0.51 you will get 0.49. But P value, that is 0.7 when you do this, and the Q value we already know, that is 0.3. So this is the formula for finding out the frequency of the dominant allele. P square plus 2PQ. So P square you will have 0.49. Okay. So now for value of 2PQ, heterozygous dominant is 2 into P, the value of P is 0.7 and the Q is 0.3. So if you multiply, you will get 0.42. Okay. So now the frequency of the total dominant is the 0.49. Okay. Plus the 0.42. So the overall the frequency of the dominant allele is 0.91. So it is around 91%. So in this population, 91% people are the dominant individuals. Clear? The third numerical problem is brown hair, that is capital B, is dominant to blonde hair small b. So if there are 168 brown hair, that means dominant people in a population of 200. Okay, out of 200, 168 are dominant. So dominant, you can even take it as P square is a dominant. Why dominant? Because it is a homozygous dominant. Then 2PQ, this is also dominant but heterozygous dominant. Okay, so this two together, how many dominants are there? 168 dominant out of 200 individuals. Okay, right. So now totally you got 168 out of 200. Now the frequency of, find out the frequency of heterozygous dominant, frequency of homozygous dominant, then frequency of homozygous recessive. Okay, so these three things together we are finding out. So after this you will become very clear regarding finding out any one, either frequency of dominant, heterozygous or homozygous dominant or homozygous recessive, whatever it may be. Okay, so with this we will complete. So now we got out of 168 brown hair people, that is dominant, out of 200, 168 are dominant. So we are finding out the different things: heterozygous dominant, homozygous dominant, homozygous recessive. So P square is a formula for P square denotes for homozygous dominant. 2PQ heterozygous dominant. So together we have 168 divided by 200. So now what is the formula here? That is P square plus 2PQ plus Q square is equal to 1. So this is the formula. Okay, right. So now here this together P square and 2PQ we have 168 divided by 200 plus this Q square is equal to 1. Okay, right. So now we have to find out the Q value of this Q square. The Q square is equal to 1 minus 168 divided by 200. And to make this 2 equal, this 200 into 1. So you get 200 minus 168 divided by 200. Now what you will get? You will get 32 divided by 200 and the Q value is 0.16. This is a Q square value. So what is the Q value? That is 0.4 is a Q value. Okay, right. So now you got the Q value. So what will be the P value? That is 0.6. Okay, so this is the P value. This is the Q value. Okay, right. So together. So now what you are going to do? You are going to find out heterozygous dominant. Heterozygous dominant, what is the formula? That is heterozygous dominant is 2PQ is equal to, so 2 into the value of P is 0.6 into the value of Q is 0.4. So we get, if you multiply this, you will get 0.48. So 0.48. So it is around, if you divide by 100, you will get 48 percentage. Okay. So the 0.48 is the heterozygous dominant. Clear, right? So now what is the value for the homozygous dominant? Homozygous dominant is p square. So p square you will have 0.6. So within bracket, that is 0.6 square. So you will get 0.36. So this is the value of the homozygous dominant. Clear? And finally, homozygous recessive, that is q square. So q square you will get 0.4 in the bracket, that is square. So you will get 0.16. So this is the value of, I'll write it here, so 0.16. So this is the value of the q square. Okay, so in this out of 200, 168 are brown dominant. So the frequency of the heterozygous dominant is 0.48 and the homozygous dominant is 0.36 and the homozygous recessive is 0.60. So based on this, you may have or may not have some questions. It may be for your compulsory 3 mark also, 1 mark also. So it is highly important. You will not search in book, you will not find it in your state board book. It's a need based question, but still they will be asking, because last year and all we had a compulsory 3 mark need based only. Before year we had a 1 mark question as well as compulsory 3 mark question based on the need based. So you may have this kind of application oriented question. So this may help you in order to find out. So during your exams and all, I will be giving these kind of problems for discussing. Clear? So thank you.